Okay guys, we had discussed about the TT system, how the three-phase RCD have to be installed. Now we are going to check the nuisance tripping due to wrong operation of the RCD. The one reason here can be due to wrong selection of the phase. As I mentioned in class, we should consider three phase and neutral at the same time, as you can see by here also, because during some unbalanced condition the three phase current will not be zero, so hence the operation of RCD expected for that one. But the major problem for the RCD operation are coming from switching and lightning. So switching transients such as the motor switching in rush current, or transient of the transformer switching, which contains the second harmonic for the motors contains third harmonic, will affect the RCD operation. So in the case of the end users home and end users customers application, means a small one, there is no significant problem for the RCDs except for those who are affected by the harmonics. But in the case of the end users such as the factories, of course the starting of the motors transformer will be affected. Yeah, here is talking about the rush current of the motors. Protection without automatic disconnection of supply is a passive means of protection. This protection is not involving disconnection of supply. It can be used to prevent the occurrence of hazardous situation in case of failure of basic insulation. Sometimes I mentioned this one about this case. I talk about the auto-recloser. So if you can remember the auto-recloser operation, somehow we can see this one. In this way, the continuity of service is preserved, which is particularly important in installation where the losses of energy can be determinal to safety, such as hospital or any chemical companies. That one is not related to safety, but really wasting a huge money. The next slide talking about class 2 equipment for insulation of them. The class 2 equipment essentially protects against insulation breakdown, either by encasing all metal parts in insulation, or by interposing two separate layer of insulation, means double insulation between the live part and extra metal, so that both sets of insulation would have to break down to constitute a hazard. Many small appliances are double insulated, such as something you usually means the engineer usually use, such as electrical drill or sewing machines. Here you can see the figure how these are and how they are installed for class 2 equipment. If the basic insulation fail, in order to prevent the appearance of the potential on the exposed conductive part, means ECPs, of electrical items, supplementary and independent layer of insulation material may be added to safeguard person against indirect contact. So this is the class 2. To reduce the probability of simultaneous failure of two insulation, manufacturer must install and test them in a way that allow a degree of independence from same deteriorating factor for both insulation. So we have to consider this one. But of course you can use one means in the same material but with more layer. This one can gives that means somehow can be interpreted as a two-layer protection. Instead of two independent layers, I mentioned this one, it can be considered as the same degree of protection against electrical shock as a double insulation. This equivalent measure is defined as a reinforced insulation. So the measure through the non-conducting nature of location itself is intended to prevent the exposed to dangerous potential difference between simultaneous accessible part or between live part and the earth. Insulation of the location avoids or drastically limit the current circulating through the person's body in the case of contact with faulty equipment. So sometimes we insulate a room or premises. In the case of danger, I can give you example for this one as I have in mind. For example, most of the playground are covered with thick PVC, which these are protecting the kids and the location in the case of the electrocution. But our talks are not considering mostly means specifically considering the playgrounds, but mostly focusing on the premises of the operation for the engineering. So non-conducting location must have insulation floor and walls characterized by the resistance to ground of 50 kilo ohms for the voltage less than 500 and 100 kilo ohms for the voltages between 500 and 1K. This measurement, like class 2 equipment, relies on two layers of protection, which is basic insulation of equipment and basic insulation of location. Equipment in non-conducting location must not be connected to the earthing system. The connection of the ground would introduce a zero potential into premises, defeating the purpose of having a location insulated from ground. Thus, class 0 equipment, which is the items with the basic insulation and without bonding terminal, must be used in non-conducting location. In addition, arrangements to also keep insulated EXCPs such as radiators must be in place. So you can see this one, the radiator here at the right hand side is somehow insulated. So the guy here, as you can see at the mid, if touching the class 0 ECPs at the left hand side, on the other hand cannot touch the right hand side because the distance is more than or something more than 2 meter, 2.5 meter. Yeah, it's mentioned by here. The ECP must be properly separated from each other by spacing not less than 2.5 meter. If the ECP cannot be separated by this distance 2.5, the interposition of the obstacles between ECPs should consider. So if cannot this distance considered, you as engineer and the safety rules have to put some obstacles between these two. So in the condition shown in figure below, indirect contact caused by breakdown of the basic insulation of the equipment is not dangerous since person cannot be exposed to any potential difference. So the floor is insulated. If you touch the voltage indirectly, there is no potential difference here because the ground is somehow insulated, so there is no zero for that one. You will affected by the voltage, but you cannot feel that one. Protection by the non-conductive location, because of its delicate nature, is suitable only for installation strictly supervised by qualified person. The key feature of this protection is to absence of any earth reference, which might be introduced into premises by unaware person via portable ground equipment supplied by extension cord and EXCPs. In earth-free locations, the appearance of the dangerous touch voltage is prevented by the means of the local equipotential bounding conductors. So, in the case of failure of basic insulation, such conductor, by connecting together both simultaneous accessible Class A equipment supplied by different phase conductor and the conductors and the floor, if conductive, can prevent or reduce the appearance of dangerous potential difference in the installation being protected. So here you can see earth-free area which is protected using PVC or anything to what we call it, removing the earth, means removing the zero potential. And beside that one you can see a earth area, so that earth area is a danger for that one. If the guy don't know the area, or don't know means the person don't know about the earth free area, can put his leg on the both, can put his feet on the both areas, then the free earth area is not exist anymore, and everything on the free earth area is under a potential voltage. So this is a danger for that areas. And you can see here at the top the EBC, or equipotential bounding protection for both ECPs considered. Electrical separation uses a supply from an insulation transformer, motor generator set, uninterrupted power supply or UPS, and etc. The output of the supply must be separated from the input by double insulation. That is, the supply devices have two electrically separated windings or circuit which ensure that there is no potential difference between secondary supply terminal and the earth or the primary supply, making shock hazards removed. So for this one, usually I can address a transformer. They call it insulation isolated transformer or isolation transformer. That transformer is used to separate the voltages level, or not only these transformer have the same voltage level, but the voltages, what we call it, windings, are totally isolated from each other. So this provides us an insulation area or electrical separation. You can see a transformer by here. So here is an example referring to the figure. The voltage present on the supply side, the same, both should be the same, 230 or 240. And on the output side, the voltage also the same. It is on-earth isolated supply, which considerably reduce the shock hazard. For this reason, the system must not be connected to the earth or exposed to extraneous conductive part EXCP or any other system. In addition, where more than one item is supplied by separated circuit, exposed conductive part of the circuit must be equipotentially bounded by an insulated conductor. And here is Appendix C. You can see the systems, how the RCDs are used in the TT system. This is used for the appliance, how three-phase, single-phase, and for TN system also you can see how they are installed for TN system, TNS system. TNCS system also we can use the RCD. An example of RCD application note, you can go through these slides by yourself. Thank you.